today we begin a real important topic, which is slope. And I've already talked about the fact that slope is delta y over delta x. But that really does have a mathematical connection. Delta means difference. Okay, that is the Greek letter delta. And the reason that I've always used that song is so that people remember that the change in y goes on top. All right? You know it this way as y2 minus y1 over x2 minus x1, which is easy enough. But a lot of people get the x's and y's flipped around, which is why I've always used the song delta y over delta x. But there's some other important ideas here. Back in the day, you learned that as rise over run. Change in y over change in x. But there's some other, you remember that idea. I've got a line here. Change in y or rise over change in x, the run. In other words, it's telling me how steep the line is. I'm going to give you several key bullets over here. How steep is the line? Okay? Slope helps me answer that question. But there are other things that are even more important as we make the bridge between pre-calculus and calculus. And here they are. We're going to talk about the ideas about this telling me the average rate of change. The average rate of change. Think change in distance over change in time. If I knew that I drove 240 miles in 4 hours, my average rate of change would be 60 miles per hour. And we could think of that on a graph. I could put my distance here and my time here. And that idea is critical as we move from pre-calculus into calculus, that we understand that slope is the average rate of change. And there will be problems to that effect on your next test. We could also say how fast is the line changing? You all know that I am a cyclist, and I also like to hike, and most certainly I can tell the difference on my bike when I'm going up a steeper hill. All right? I have to gear down. The pedaling is harder. It's more of a workout. It's the same thing when you're hiking. Okay? The steeper the hill, all right, you definitely know it. Okay? So we're talking about how fast are things changing and this idea of the average rate of change. The math today is not going to be real hard. But the idea and the concept as we move through this unit is going to be very important. All right? So, to begin, you're going to have problems like this where they tell you to find the slope of the line. The math is not going to be hard. They'll give you 2 points, -5, -7. And -8, 3. They're going to ask, what's the slope of the line that goes through those 2 points? So, we're going to use slope is delta y over delta x. Singing the song helps me remember that the change in y goes on top. So here's a y value, -7 minus 3. That's the change in y. It's on top. The change in x goes on bottom. I'll do that in red. The change in x is -5 minus a -8. Notice I'm writing it as minus a -8 because a lot of people get in a hurry and ignore that fact, and they miss the fact that this becomes -5 plus 8 on the bottom. Be careful with your steps even on this simple math. The top, of course, is -7 minus 3, and the slope of this line is -10/3. And we would say that this line is decreasing. Wouldn't we? It has a negative slope. The negative slope tells me that the line's going down like this, somewhat. All right? I'm going to give you another term that you need to write down from this page. And it is right here in the middle. This thing has a special name that's going to go with us all the way into calculus, and that is, this is called a difference quotient. And I think you can see why it's called a difference quotient. I've got a difference divided by another difference. Quotient stands for division. When I have something minus something divided by something minus something, we call that a difference quotient. That term is going to go clear into AP Calculus. All right, so I want to make sure that you see that connection. Next, what if they ask you to find the slope of a line that goes through points that are fractions? Now, we don't panic. We don't call 911. I've taught you how to deal with fractions. The process is the same. You just have to use what we know about fractions. So it's still delta y over delta x. But now I'm doing the work with fractions. And I expect, as pre-calculus students, you should be able to do this without a calculator. -5/3 minus 1/6 is on top. And on bottom, I have 2/7 minus a -12/7. Well, we'll do the easy part first. The bottom already has a common denominator, so I just add those two, and I get 14/7 on the bottom. But on top, I need to get a common denominator. What's the common denominator on top? 6, right? So this first fraction, I need to change into -10/6. Multiply the top and bottom by 2. And now I can subtract. -10 minus 1 is -11/6. Now, of course, this 14/7 is the same thing as 2/1. When I divide by a fraction, I multiply by the reciprocal. So I'm going to multiply this by 1/2. And I get that the slope of this line is -11/12. We use the letter M for slope. Once again, this line is decreasing from left to right. Hitting the key big ideas here today with slope. The next one is slope-intercept. The slope-intercept equation is y equals mx plus b. That's the slope-intercept equation. It's not the only one we use. M is the slope. What's B? The y-intercept, good. The y-intercept. So you're going to have problems tonight where they ask you to find the slope, the y-intercept, and graph. Now, I'm not going to do one like this. If you see y equals negative 2x plus 5, I'm not going to go over that because it's already done. The slope is negative 2, and the y-intercept's 5, and you graph it. I want to do one like this that's not ready to go. One like 3x plus 4y equals 16. This one is not in slope-intercept form, so we've got a little bit of algebra to do first. I need it to be in this form. So I need to subtract 3x first. And I have 4y equals negative 3x plus 16. And then I need to divide both sides by 4. Make sure you divide all the terms by 4. And now I have it in slope-intercept form. Y equals negative 3/4 x plus 4. The slope is negative 3/4. There's the slope. The y-intercept is 4. Now graphing it, I expect you to do by hand, not with the graphing calculator, because you have to make this connection. It's important that we have connections in this slope work that we're doing. The y-intercept is 4, and that's where I begin the graph. I begin the graph at the y-intercept of 4, and I go down 1, 2, 3, and over 1, 2, 3, 4 to get the next point. And there's my graph. It seems like the decreasing function is popular today. Now what if they give you this one? Y equals 5. What if they just give you y equals 5 and they say, what's the slope and y-intercept? I don't see an x term. Well, that's because the slope of this thing is 0. It's horizontal. There's no work to do on this one other than the graph. The slope is 0. It's horizontal. Its y-intercept is 5. All you have to do is draw a horizontal line through 5 and recognize that the slope is 0. If it's a horizontal line, if it's a flat horizontal line, the slope is 0. All right, our last big topic for today when we talk about slope is a very important equation that a lot of young algebra students don't spend enough time with. And so I force my pre-calculus students to spend more time with the point-slope equation. The point-slope equation is very handy when I know a point and I know a slope. So the point-slope equation is y minus y1 equals m times x minus x1. That's the point-slope equation. And where we use it is on a problem. I'm going to do a couple problems. Here's the first one. They're going to say something like, write the equation. Write the equation of the line. and they're going to give you kind of different pieces of information. On this first problem, they're going to tell you that the slope of this line is -2, and the line passes through goes through the point -3.7. So look what I've been given, everybody. I've been given a point, and I've been given a slope. So when I'm given a point and a slope, the most efficient way to get an equation is with the point-slope equation, not the slope-intercept equation. Okay? Don't use slope-intercept. I'm going to require you to use the point-slope equation. So we're going to use y minus y1 equals m times x minus x1. And we're going to plug in. This is my x1, this is my y1. So I have y minus 7 equals, here's my slope, -2 times x minus -3. Just plugging those things in. So you have y minus 7 equals, this is x plus 6, I'm sorry, x plus 3. Sorry about that. It'll be a 6 after we distribute. So I distribute through and I have -2x minus 6. And then I add 7, and now I have the equation of the line. Y equals -2x plus 1. All right? Using the point-slope equation. We're going to have problems tonight where I want you to use the point-slope equation. If they tell you to write the answer in slope-intercept form, we did. Okay? We did write it in slope-intercept form, but we used the point-slope equation to get there. All right? Now, I told you they'll give you different pieces of information. What if this is the information that they give you? And this will be our last problem. What if they tell you that this line passes through these 2 points? That's all they give you. This line passes through those 2 points. If I'm going to write an equation, no matter what, I've got to know the slope. So this one has an extra step. I need to find the slope first. So delta y over delta x, that's 4 minus 12 over -5 minus 3. That's -8 over -8, which is +1. The slope is 1. Slope's 1. And now I have a point and a slope. I've actually got 2 points. You can use either one. It does not matter which point you use. Both will work. All right? Both will work. So I'll use the one that's got 3 and 12 since it's got nice, pretty positive numbers. Y minus 12 equals 1 times x minus 3. So y minus 12 equals x minus 3. Add 12, and we have our equation of the line, y equals x plus 9. The y-intercept is 9. What's the slope of this line, by the way? 1. Slope is 1. And we will stop there for today.